Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true, every little bit counts.
AFM.
Program complete. Enter when ready.
The curtain of night is drawn back. The telescopes are trained. The domes are open. The audience is set. Now, step into the event horizon.
Good evening, everyone, and welcome to the event horizon here on Astronomy.FM radio. It is another Friday evening.
What do we do every Friday evening, Marty? We take over the world.
Sure.
Galaxy. Thank you, Starstorm. Galaxy. Does that mean I'm Star-Lord?
No. Sith or something.
Pardon, Starstorm?
Thanos, maybe, not Star-Lord.
You heard it, folks. I am Thanos.
So introduce yourself, Nick.
Good evening, everyone. It's me, Nick Evetts, KC2VWR mobile, or not mobile, fixed base at the moment, or 2 Echo Zero Lima Uniform November. I'm back.
And what Friday is this?
This is Friday the 23rd in the Eastern Time Zone of the United States.
Mm-hmm.
Saturday morning, 2 a.m., or 2:01 actually, if you're in the United Kingdom.
Yep. Well, if in that time zone. What time zone is that?
Pardon?
What time zone is that?
Oh, that's good old GMT.
Greenwich Mean Time.
Greenwich Mean Time, yes.
Okay.
The zero meridian of the world.
There you go. So that also means our chat room is hopping. So come on over and join us. Go to the homepage of Astronomy.FM. You'll see near the top where it says Radio Chat. Click on that. You'll see a whole bunch of stuff. Ignore most of it. Type it where it says your name.
I'm going to tell Tabby and Ocean Star you said that.
Okay. What is most? You do ignore most of it. So you just type in your name and you hit login. You don't need the password. You don't need the rest of it. So hit that and you'll be in our chat room.
Glenn is already starting to ask questions in the chat room. Does the British have one time zone? No, Glenn, just the one, mate. Good old Greenwich. Well, we have Greenwich Mean Time and we have British Summertime, but it's still the same time zone technically.
Okay. So the GMT line is right down, still in the same time zone, no matter what side of the line you're on.
Oh yes, zero meridian, straight the way through Greenwich in the city of London.
Okay, it's kind of like
the French missed out very nicely.
It's kind of like that here too, where I think 75 degrees is the center timeline, and that kind of goes right through to Toronto, Canada, north and south, basically. So I'm definitely west of that point, and you're east of that point, but not equal distances. In fact, where I'm at here in Michigan, some political thing said, Michigan wants to be in the Eastern time zone. We really should be in Central, but we're going to make it Michigan anyways. It was kind of a political business thing. So we're actually like 32 minutes west of the Eastern time zone meridian.
Okay, now what we're talking about is a prime meridian. It's a meridian in a geographic coordinate system, of which longitude is defined to be 0.
Mm-hmm.
So it's together a prime meridian and its anti-meridian form a great circle. This great circle divides the sphere, i.e. the Earth, into 2 hemispheres. We have the equator straight across the middle of the Earth. However, there was almost an attempt by the French to have the prime meridian there in Paris, but it failed.
Mm-hmm.
So the prime meridian is based at the Royal Observatory, Greenwich. It was established by Sir George Airy in 1851. By about 1884,
and thus starts the history rant.
Yeah. Over 2/3 of all ships and tonnage used it as a reference meridian on their charts. In October of that year, at the behest of U.S. President Chester A. Arthur, delegates from 25 nations met in Washington, D.C. for the International Meridian Conference. This conference selected the meridian passing through Greenwich as the official prime meridian due to its popularity. However, France abstained from the vote, and French maps continued to use the Paris meridian for several decades. In the 18th century, London lexicographer Malachi Postlethwaite published his Africana maps showing the meridian of London bisecting the equator a few degrees west of the later meridian and Accra, Ghana. I'll put the link in there. There's a lot of this stuff.
Something tells me you didn't say that name with a proper French accent.
Oi, oi, oi. But of course, I'm British.
So the next time you criticize American language, I'll throw the French language at you.
Well, having said that, Britain and America are two countries divided by a language. Mm-hmm. You have your version of it at the behest of one Benjamin Franklin, Esquire, and the rest of the world speaks proper English.
Yeah, which you speak differently throughout the whole country.
We have dialects. Mm-hmm. Everybody has dialects. You have it in the States. You have dialects in New York, Michigan. I've heard the Michigan accent many a time at work. You have the Southern dialect,
which has several variations in itself.
Boston accent.
Yes, the Boston Brahmin accent. Yes,
Jersey accent. Mm-hmm.
Yeah, the New Jersey accent. Yeah, I've heard of that one.
Used to be the Valley Girl accent too, but it's not so much anymore.
But the thing is, though, the problem is how we use language really defines what we're talking about. You call it a hood, I call it a bonnet. Mm-hmm. You call it. You have words like the trunk.
Trunk. Yep.
Gasoline, petrol. If you're going to be absolutely accurate, let's call it benzene. I think it was the Germans that actually patented the name at the first go. But
gasoline?
You have gasoline. The Germans have benzene.
Ah, okay.
But
benzene is something. Benzene is something else. I'll look that one up.
No, benzene is what it's called in Germany. Petrol is called Germany. It's petroleum. But okay. You do use the word petroleum.
Mm-hmm. You do?
Yes, you do. Particularly in Bissell. And yes, there is diesel, another German word.
Mm-hmm. Named after Mr. Diesel.
Absolutely, yes.
English language likes stealing from everybody else.
Yes, English is a wonderful language. It follows other languages down dark alleys and mugs them. It's the greatest thing about English is it's always evolving. It's evolution. It just grows and grows.
Good and bad. I don't like evolving languages like that.
It's annoying when they try to find new words to add to the English dictionary.
Yes, another pet beef here. All these weird and wonderful words that have to be added to the dictionary.
I know. It's like they should just drop some then if they're going to add some. I think, or should put a time limit on them for adding them in the dictionary, and then once they get out of fashion, just drop them. It'd be much better.
And of course, if you do go to London, you can get your picture taken at the Prime Meridian Monument. Mm-hmm. And there is now a laser that's projected from the Royal Greenwich Observatory, marking the Prime Meridian. Where would we be in astronomy without it?
Glenn says I should study Latin.
Floating somewhere in space.
Well, it has its benefits. It was the language of science, along with French, for a very long time.
How about Latin America?
They speak a form of Spanish.
I know.
unless it's Portuguese, but because of the colonies.
Yeah. Once in a while I speak pirate, but not on Friday nights.
Yes. International Pirate Day.
September 19th.
Yeah. And what about China or South America? Well, South America we just discussed, mostly because they were Spanish or Portuguese colonies. China speaks Mandarin or Canton. China has several dialects.
Szechuan,
Cantonese,
Mandarin.
But the dominant version is, of course, Mandarin.
Mm-hmm.
And at the moment, the Chinese government, from what I've been told by some friends who've been living over there for the last 8 years, slowly they are trying to make Mandarin the dominant
single language. Okay.
Yeah. But as I say, language is always important, because with language you can communicate. And by communicating, as Sir Winston Churchill once says, better jaw than war.
Uh-huh.
But ancient languages, yeah, fine. You have Latin for one. You have languages like Welsh, which is very much an ancient language, still alive. Manx, Cornish. The list is endless, but a lot of them are coming back.
We could talk about language all night long.
We see Latin.
We are talking about language because we're using it, Marty.
Exactly.
I wouldn't be surprised if we see Latin make a comeback.
I think you're right. I think Latin will make a comeback.
We still use it in science anyway. Text classifying living things.
There you go. This is the beauty of a live show. You know we're live because we have people joining in with their opinions, even on the radio, and that's the beauty of the show. So, what's been going on?
It's alive!
Yes, it's alive. It's like a Quatermass experiment.
Or Frankenstein's monster.
Yeah.
Which was one big science experiment anyway.
Yeah, true. You know what? Let's start with the moon, shall we, Marty?
Let's start with the moon. What about the moon?
Well, this is a nice L-pod from originally published September 21st, 2008. I love L-pod.
Wait. Tell everybody what L-pod is.
Okay, it's Lunar Picture of the Day.
Okay.
Charles Wood was the editor-in-chief, and he actually pays to keep the site up, along with the Moon Wiki. But the nice thing is about this site is you have some very wonderful imaging of the moon. Mm-hmm. Some of it is professional. Some of it is from probes like JAXA's and from Changi, and there's even Apollo and Ranger images frequently coming up. But the majority of the images are amateur astronomers. They're using light bucket telescopes in a lot of cases, and this particular one is of the Apennines, and it is related to Ruckle plates 22 and 23. Saying that, what comes in the post for me this week? I got myself a Ruckle Lunar Atlas at last.
Yeah. I think it was Black Projects that was mentioning earlier to me about a picture he took on. You could see the Lunar X and the Lunar Y. I've never heard of the Lunar Y. Are you familiar with that?
I think I know what he's talking about. The Lunar X, of course, is around Wenger, but Lunar Y, let me just pull that up.
Okay.
But as I say, it basically both of these are really optical illusions.
Well, plus there's no actual Y or X on the moon.
No.
They're all optical illusions. So what it is, it's a feature on the moon that you can actually see when the light is just right. So
Actually there.
the only way to change the lighting on the moon is during its orbit, so that the line between daytime and nighttime, the terminator, it shifts its position from one side of the moon to the other side of the moon, and basically sidelighting a lot of features. And then when it does that just in the right way, there's certain features that actually stand out. So in order to be able to see these features, you have to look at the moon at the right time in its orbit in order to get the terminator in just the right spot to be able to illuminate certain features. Like sometimes if you just look at the terminator, you might see a pretty good sized crater, but and that's inside of it's all black, but you might notice a white spot in the middle of it. That would be a mountain peak sticking up in the middle of the crater. And the only time you'll be able to see it like that is when that crater is right on the terminator.
Okay, I've put an image into a link in the chat.
Okay.
What is the Lunar X? Now, a lot of people go, oh, it's an alien visitation. Rubbish. It's a famous optical feature. It's visible through telescopes. It's when the terminator, or the line between the light and dark on the moon, is located just in the right place. It appears like a letter X on the lunar surface.
Mm-hmm.
Basically, it's an illusion that's created by sunlight falling on the rims and ridges between craters Lechseli, Becanus, and Purbach. Now, if you look at the way the sun's light moves across it, it is a case of it's lighting up the actual rims of the craters. It's normally first quarter moon, just before first quarter for the lunar X.
And the V too. Looks like the lunar V is pretty much the same phase.
Yes. So this picture in this particular Earth sky was taken by Raven Yu. I believe she's in the Philippines back in 2013. Now, is BP is sick. BP is, I think he's fallen asleep.
Okay.
the hours have caught up with him.
Oh yeah, he's after 2 in the mornings. Not here tonight. Yeah.
Yeah. So as I say, Starstorm's put a link into chat for us as well about the Matrix.
Great.
Not the movie.
Not the movie.
The actual definition.
The actual definition, as she quite correctly points out.
What matrix is this?
Something within a form which something else originates, develops, or takes form, an atmosphere of understanding and friendliness. That is the matrix. They're saying the matrix of peace here. But it goes into what can actually cause an image. It could be a circuit. It could be mathematical. So there's various definitions from the Merriam-Webster dictionary on what a matrix is.
Okay. I've heard of the Lunar X, never really looked for it. I don't know if I might have seen it, and never heard of the Lunar V, but I'm going to have to definitely try for that. I have seen the Straight Wall.
Yeah.
Have you seen that?
I believe I've seen it. As I say, it's been a long time since I've actually had my own telescope. My scope at the moment, I've got back from the UK, and when I went to get the scope out, guess what I forgot and left over there?
Eyepieces.
No, the counterweight.
Yeah, that makes it very difficult to use a telescope without a counterweight.
Yeah, particularly a 10-inch Newtonian.
Yeah, sometimes you get creative if you have something like, a backpack. You can hang it on the bar, and you can do a little bit of observations as long as that counterweight bar is not like pointing down towards the ground and your backpack slides off. So if it's mostly horizontal, you kind of look around a little bit, making a counterweight out of a backpack and whatever stuff you can throw into it. It can be done for limited observing. Yeah, I've seen people that forget their tripod, or they have the tripod, their scope, but no mount. Counterweights, yep. Eyepieces, cameras left behind. I've heard of pretty much everything being pulled out of the bag and left in the house.
Yeah, that's one thing I don't have to worry about, Marty. I don't use eyepieces. I've gone to the dark side, mate. I'm an imager. Now, if you scroll
with
down
your own scope, right? Is what you're going to do?
A scope, yeah. Or I use remote telescopes as well.
Mm-hmm.
Now, if you scroll down in the Earth Sky article, there is actually a picture of the Lunar V.
Down a little down, halfway down or so. Yeah. I see that. I'll have to try for that.
Yeah.
Have you ever seen the Alpine Valley?
I have seen the Alpine Valley, yes.
Yeah, alrighty. A few features I kind of remember. A few rills, which are basically, they used to say collapsed lava tubes. I don't know if they still call them that or not. But basically, kind of like what looks sort of like a dry river on the moon. I've seen things like that. Some very interesting dark craters, smaller, or like oversized Mare. What was it? Grimaldi. I think it's Grimaldi's really, really dark spot.
Now, if you're really interested in the moon and you was looking for places to go and crater hop to, I'm going to put another link in. This is from a chap called Andrew Plank.
Okay.
He has wrote a book called What's Hot on the Moon Tonight. I actually own a copy of the book. I think it's actually quite brilliant because it's a spiral-bound book and it gives you targets, and they have blank pages that if you want to sketch and put in notes, you can do. Obviously, I'm using my computer to do it for my notes because I've got Sky Tools, and that to me is brilliant. I also use Virtual Moon Atlas because that will actually sync up with my mount, and I can actually create a hop that way as well if I really want to be totally on the dark side. Now, as I say, this is, at the moment, the newsletter he's got out is for the week of February the 19th to the 25th. So, there's 2 craters that are showing. One is Urima Arideus, which is named after the 7-mile crater located near its northern end. Notice that the crater has a slightly smaller companion, touching on its northeast side. Their rims are gently pushing into each other. Can you tell which is the older crater? And there's Walther, southwest N9. Now, the nomenclature he's using is in reference to the Sky and Telescope field map. So, for instance, for Plato, he's talking about northwest quadrant D9, L equals 9 degrees west. So you open the field map to the northwest quadrant, grid D9, and Plato is at longitude 9 west. Now, having a longitude for a feature is enormously helpful if you're planning an observation, because any object which is within 15 degrees of the terminator will stand out with astonishing detail. This, to me, is one of the greatest things about lunar observing and imaging. It's always changing. Because of the way the sun actually strikes the lunar surface and the way the daylight actually walks across the moon, for want of a better term, it not only will expose features, but sometimes it will even highlight them. So everybody says, "Oh, the moon's boring; it's full." No, because you can use the Mare to navigate, and you can find larger craters, and there's always something you can see, which is going to be visible to the eye. Yes, you're going to need a filter. It always helps. But depending on the aperture of your scope. Depends on the aperture of your scope, yeah. But as I say, I'm using instruments 10 inches and up. And if I'm imaging, I am going to be using a moon filter. That's about 13% transmission, because that way I can focus it easier and I can see more. Now, as I say, the other great thing, of course, is it's not a dead world. Even NASA has a observation program currently still running. It's been running for about 10 years now for lunar impactors. Now, this is really something you're doing when the moon is waxing. You stop at full moon, and as the moon begins to wane again, you're looking for bright impacts. A lot of the time, you're using a video camera to record it, and you're using an interferometer because you need to impose things like GPS coordinates and a time. Very important, this. If you're actually looking for impactors, they need to know the exact moment of the flash. So again, it is quite a complex system. Brian Kudnick has a book out about lunar impactors and how to observe them, and he runs the NASA program. And why is NASA running the program? Because they do want to go back to the moon. And knowing the frequency of impacts, it is a case of they can look at where is a better area to perhaps situate lunar habitats. And of course, with the lava tubes as well, they would provide a very handy place for radiation shielding. The moon has no atmosphere to speak of. It has a very thin exosphere, and that's about it. So the obviously solar radiation and solar storms are an issue. So perhaps building shelters in nearby lava tubes would be a possibility. The moon was very, very active millennia ago. We know that from the impacts, and you can always tell an age of a crater. In a lot of cases, you'll have large craters with a peppering of smaller craters inside. Those smaller craters are going to be younger than perhaps the larger crater, which would have been a major impact. And of course, the central peak in a lot of these craters is part of the actual impact. This is, in a lot of cases, they believe that the actual spike is material that has solidified,
rebounded
from the actual impact. It's one of those really fascinating things. I can sit there, I can read Brian's book, I can read Patrick's, I can just look through my Rucal. I've actually bought 2 other books by a chap called John Moore. One is Features of the Near Side of the Moon and Craters of the Near Side. Get to know the moon. It's there majority of the month, and you can just follow it from looking and trying to image the first thin crescent all the way to the faintest waning crescent. Always something you can do.
Yep.
And we are going to go back because at the end of the day, where are you going to test the equipment for Mars? The moon. Where are you going to make sure everything works, because without really risking a team, is the moon, because you can put a space station up there. They can have other vehicles ready to retrieve scientists and explorers if there's an issue. And the other big thing is, it is a cauldron of elements. Aluminium, titanium, to just name 2, are available on the moon. So something our industries are going to need is going to be those elements further down the road. So eventually we will probably be mining the moon and mining the asteroid belt. So it is a tremendous resource, and of course it does another good thing for us. It takes an awful lot of the inbound objects that otherwise might do a bit of damage to us. The first thing they're probably going to hit, quite likely, is the moon. Better it hits the moon than it hits us in a lot of cases. We've had our wake-up call at Chelyabinsk, Barringer Crater, Chicxulub. We have a Chicxulub event today. That would be very, very devastating, not only for us as a species, but for most species. Yes, I am Glenn, and I love the moon. I think it's brilliant.
It's not dead.
It's not dead. Yes.
Yeah.
But the great thing is, I like galaxies and nebulae too. I love comets, but sometimes, well,
the dark side.
Yeah, the dark side.
You gotta revisit the moon every once in a while. It's like, you think it's easy to photograph. Well, I've tried lots of photographs of the moon, and it's not that easy. There's a lot of air turbulence. For one thing, you have to get over. Like, you look at the moon through your telescope, oh, this looks great. Just think you can just pop your camera on there and take a picture, and all of a sudden you find out, no, it's actually kind of blurry and fuzzy, and it seems like it's not really focused, even though you thought it was perfect focus. Like, that's a lot of air turbulence messing stuff up like that. So you can spend a lot of time to get good results in lunar photography. You have to practice a lot.
And of course, it's really great because it is the most convenient thing to practice your early astronomical imaging on.
Yeah.
You can fine-tune your telescopes, your camera setups, your software, all on the moon. And then you can go out, then you can start putting in 2 hours at a time on subs at using various filters to get nebulae and galaxies.
It's always good to go back to the moon and practice your astrophotography, even if you've been doing it for a while. Go back and see especially when you start comparing it to other people that have done a lot of lunar photography. It's like they have some amazing pictures that it actually takes a lot of work to get there.
Yes, it does. Some of the actual mosaics I've seen done. People don't realize one of the most important moon maps used for Apollo was by Patrick Moore. I have a copy of that moon map. He actually drew a map of the moon and put the craters in, the rills, the ridges, everything. And it was a hand-drawn map. And it was one of the first things NASA went to actually so they could start planning man on the moon, was because they needed to have accurate maps, and there really wasn't that many. Then the U.S. Geological Survey started imaging and mapping the moon to quite a high definition. I've got a set of those maps that USGS does. They're brilliant. Again, it's something you can spend hours and just forget about the passing of time. You can just you can sit there, you can lean back, you can use your binoculars, you can use your telescopes, you can even try and find the smallest possible crater with your naked eye if you've got good vision. So how many mass extinctions? Probably quite a few. That the Moon and Jupiter has been very, very good to us. Jupiter has a great habit of being a vacuum cleaner of the solar system. It sucks in those killer rocks. If they get past there's a good chance the Moon will take it. And every now and again,
smaller things hit.
Yeah. As I say, we've had our wake-up call in our own time. Chelyabinsk was one of them. You could probably say Tanganyiska was also one of them in our times. Yeah, I guess it was. Early 20th century, yeah.
And Chelyabinsk.
Chelyabinsk, yeah.
I mean...
I'm sorry, my Russian is not that good.
Not as good as your non-French.
Bottom of the hour, mate. Go for it.
I know. You're listening to the Event Horizon here on Astronomy.FM. That means it is another Friday evening, halfway through our program right now. This is Friday's February the 23rd of 2018, about 9:30 in the evening for those of us in the eastern portion of North America. So Universal Time, that would put it Saturday morning at 2:30 in the morning, February the 24th, 2018. Don't forget, come on over to our chat room. That's when all the action happens during our live presentation like this. So come on over, join us. There's several people in the chat room. You can ask them questions. You can ask us questions. We'll answer them on the air as best we can. So come on over and join us. Another half hour of the show. And then, of course, after that, we've got more programming coming up for you. For instance, we have, what do we have tonight?
Sky Talk, International Space Station Grounded. We have Talking Space. We have today's 365 Days of Astronomy.
So we usually have about 4 hours of programming that we repeat every 4 hours for the next 24 hours. So if you missed some of it, you can catch it a little bit later in the day until the next edition.
That's the great thing about Astronomy.FM. We play real science. That's Sometimes it's going to be biology and chemistry, but it's all part of the rich mix of science. And that's the important thing, is getting the word out, getting people to listen to real science, not this pseudo gobbledygook like Planet X is going to come into the solar system and we're going to be hit like a snooker ball off the cushion. One thing.
Without anybody knowing it.
Comment about the far side of the moon being really battered. It is really, really battered.
With smaller craters.
Smaller craters, yeah.
Because this side is bombarded with bigger craters, which made those Mare, those giant dark spots. Mare means seas. So basically, they had the big rocks hit our side. Lava welled up from underneath and filled in a lot of the little craters. So that didn't happen on the far side. It happened on our side.
Now, Starstorm wants to read something out, and I totally find this hilarious because I actually posted it originally.
Some say he performed an orbital drop in a sports car. Others say he's badly retroscoped. All we know is he's called the Stig.
Yes, we're referring to Starman and the Tesla.
Okay.
No, but seriously, let's quickly let's get this. I know it's been a while since anybody's talked about it. Everybody says, yeah, great publicity stunt for his car company. It got people paying attention. The fact that he's actually managed to launch it. He's proven heavy Falcon. He's then
successful launch to begin with.
Oh yeah, he sent the car through the Van Allen belts, and more importantly, he's done something which is very important. He's proved that you can restart an engine multiple times, and then make correct orbital corrections, and not have to use small thrusters, but the main engine.
as long as you have the restart fuel.
As long as you got the fuel. But that was the important thing.
Which I didn't look up. Is it might be that those two chemicals you mix together and they automatically ignite. I'm assuming that's what they meant by the ignition fuel to light your main engines.
But the important thing is really with Heavy Falcon and with the third stage, he's proven the fact that he has a workable engine that can be started, it can be stopped, it can be started, and it can be stopped. Mm-hmm. One of the most important things is being able to make corrections using your main engine. And in a lot of cases, most of the time when you're boosting an object into space, you have your main burn to clear the atmosphere, you drop the stage, you ignite your second stage to go to where you want to put your satellite or whatever it is, or your Tesla, and then you just deploy it. Now he's gone one step further. He's actually taken the thing beyond Earth orbit. He overstepped it a bit, but I think they knew they were going to do that.
That was on purpose, yeah.
Well, yeah, because the thing is, the U.S. Air Force wanted proof that the engine would work on multiple times, multiple burns, in the environment of beyond high Earth orbit. So he's done the most important thing, which was to certify the whole rocket as a feasible platform. I would like to see him not only just do his BFG or BFR. I want to see him produce a version of BFR that can carry Orion. Because I think a lot of people are going to say, well, why bother with SLS? Why bother now that SpaceX can do it? SpaceX has competition. It is in the shape of Amazon's Steve Bezos. He's got a nice rocket, the Glenn.
I think SLS is still a bigger rocket, isn't it?
Yeah, but the problem is poor old SLS, like Ares, is being dogged with setbacks. Mm-hmm. They appropriate. You can go spend this on SLS. No, we're taking it back. Now you can have it back. Now you're taking it back. The problem is, if SLS is going to be a viable system, they have to have the funding. They also have to have the ability to build more than 2 rockets a year. Mm-hmm.
I mean, launch 2 rockets a year.
No, build.
Build 2 rockets?
Boeing are having a problem meeting the requirement. They cannot build more than 2 rockets a year.
Oh, okay.
They dropped a fuel tank for SLS when they were putting everything together.
Okay, define dropped.
It was on a crane and
it fell over.
And it fell over. Yes.
Gotcha. Okay. Yeah. Drop could be.
Ouch! I just did a Richard Hammond.
You could drop something on paper also. So I just kind of wanted the definition there.
Basically, it was being moved from A to B, and they dropped it. It's the only one they had at the time. They were doing an integration, and they dropped it.
Gravity happens.
Yeah, gravity happens, and now the program's back 2 more years. Mm-hmm. Same with Orion.
Oh well.
Sad. I hate to say this. There is no drive. No one is saying, "Yeah, we're going to stick with this. We're going to push it forward." They keep chopping and changing NASA's focus. They need to leave NASA alone. Mm-hmm. Let them get on with it. Give them more than just 0.2% of the GDP. Give them a little bit. Give them at least a good whopping half, or maybe 3/4. Mm-hmm. In today's money, if you were looking at a Saturn V, you would probably bankrupt the country, given the costs of building them. And they didn't just build one at a time. They built 2 or 3 ready for integration in the vertical assembly building at Cape Kennedy. But the important thing is it was a smoothly running production line. And yeah, I know someone's going to say, oh, well, we had the Cold War. Big deal.
But it was also putting people back to work.
It put people back to work.
You had people making gloves, people making...
That's what SpaceX is doing.
SpaceX is doing it. I agree.
Yeah.
The thing is,
I looked them up. They've got
more rockets
SpaceX has like 7,000 employees approximately,
and climbing.
Mm-hmm.
He's still hiring.
Mm-hmm.
This guy doesn't know the meaning of the word. We've got enough employees. He's got a vision, and his vision is
driven to fulfill it.
He's driven to fulfill it. He's driven to put man on Mars, and he knows he's going to have to go via the moon, but he wants to get to Mars, and he wants to expand our horizons. He is a James T. Kirk. I hate to say this.
More like a Scotty, I think.
Well, yeah, he's very good at getting his people
He's going where
enthused.
no man has gone before. I'm sorry, you put that
I
in
know,
my
I
head,
know.
and I had to get it out.
But
Glenn-
the thing is,
Glenn had a question here.
yes, go. What was that?
Did the latest first stage get lost?
They
That was
lost
on
the fairing, part of the fairing.
Oh yeah, it was a fairing. The top. That's the top of the rocket, or the part that separates. What was the fairing on that one?
Top of the rocket. It
Top of
covers
the rocket. That separates and holds the payload, right?
Yep.
Surrounds the payload. Okay, yeah, they were gonna try to recover it, basically try to catch it. Did it come down on parachute? Was that?
Well, they have a catcher ship.
Yeah, they had a catcher ship, but was the piece coming down on a parachute, or was it basically big and flat and floated down on its own? So, do you recall any information on?
The only information I've seen to date about it is the fact that where the ship was not where the fairing was. Piece of fairing was.
Mm-hmm.
They were close to each other, but not close enough.
Yeah.
Now the center core on Falcon Heavy crashed into the sea.
Yeah.
It's an easy fix. And he'll be the first to tell you that unless we have issues, we don't make progress. Thank you, Starstorm. Yes. At the end of the day, it's a case of, it's a small setback, but you know what? We have a rocket system that's reusable. It can be used 4 or 5 times, and again, and that is going to make it cheaper. I love the Saturn, the 1Bs and the 5s, but they were a one-shot rocket. But he is switching to a system where it's going to make it more and more economical to go to space, to do the thing, to put the equipment up there, to put the satellites up or the space probes up. He's got his U.S. Air Force contract for Heavy, because by proving the engine could do what it was designed to do beyond low Earth orbit, he's made it. He's proven what he wanted to do.
Glenn's talking about. I think he was talking about the Falcon Heavy, where the 2 boosters landed back at Canaveral there, but the center part, it did not.
The barge, I believe.
I don't know if it bounced off or if it hit or it went wide a little bit, because the engines, as I was talking about earlier, I think it's 2 chemicals that when you mix them together automatically ignites, and I think they use that to ignite the main engines, and they ran out of fuel for the igniter system, so it was not able to ignite all the engines. It only ignited like 1 out of 4 engines. Yeah. So it was not able to slow down enough to actually do a landing. So I don't know if it was recovered or not, but I know it went into the ocean, and I don't know if it was recovered after that. It was, obviously, it would have been crunched way too bad.
Well, the other thing was they lost contact with it as well at one point.
Did they?
Yeah. Because then they were normally saying that they have a radio. They're using telemetry to bring it in, and they lost telemetry at one point.
Okay.
But as he points out, I'm not going to worry about it, because it's one of those sort of things that we go back and we look at it, and we work with ground equipment and fix it.
It was an older version also, so
yeah. It was
they've upgraded.
It was one of those reused engine cores itself.
Mm-hmm.
So that was probably the best thing about it. It wasn't a brand spanking new engine he lost.
Mm-hmm.
It was a proven reused item.
Mhm.
Hey, live and learn.
Yep. Well, anyways, we got, since we're talking about the moon, we'll just talk about some sky stuff too. We got the first quarter moon tonight. Well, actually, technically yesterday, because we're already we're already at tomorrow. So technically it was Friday yesterday, first quarter moon, but still close enough for tonight. We also had, earlier in the day, we had the moon go in front of Aldebaran quite a few hours ago. So if you were in the right part of the world to be able to see that, which I think was like Northern Asia and stuff like that, we could see that. Thursday, March 1st, we have, the moon is going to go in front of Regulus, the bright star in Leo the Lion, Alpha Leo the Lion, and you have to be in Northern Europe and Northern Asia. No, sorry. You have to be in Greenland, Northern Canada, and Alaska to see the moon cover Alpha Leo Regulus.
Alpha Leonis, yeah.
Yeah, that's kind of about it for the moon and planets and stuff like that for this week.
I think the nice thing is, the really good thing is a lot of younger people are coming into astronomy again.
Mm-hmm.
Some of them are coming into it through cosmology and astrophysics, because it's being taught in schools. A lot of kids that I speak to on Facebook, they are in places like the Philippines, Japan, Korea. Astronomy is an important part of the curriculum. The UK has a GCSE in astronomy. It is part of the curriculum. We have the Liverpool telescopes for kids to actually log in, set up, and run imaging and actually do serious scientific work. My old mate Nick Howes is involved with that. And this is a project he's been working on with for quite a long time. And the great thing is, because there is dedicated telescopes for schools to use, it really makes it a lot easier. The other thing, of course, is telescopes are getting more and more available. The larger telescopes are becoming more and more available, especially in the West, and certainly in places like China, Japan, Korea, Singapore, and the Philippines. There are people with their own telescopes, and they open up their telescopes to school kids and have star parties.
Mm-hmm.
And that, I think, is one of the greatest things about our hobby, is we're in a position to educate. We can help the schools educate. And perhaps if you have a telescope at home, and excuse me a second, I need to mute.
Okay.
Sorry about that.
It's okie dokie.
So we need to be getting out there and being a resource for education.
I think we're doing that right now.
Oh yeah.
Very limited.
Excuse me.
Checking notices from the American Association of Variable Star Observers. Nothing right now. About 2 weeks ago, alert notice for a nova in the constellation of Scorpius, and a possible nova in M31 was reported a couple weeks ago. So nothing new on those, though.
You have a link to the chat room, Marty?
AAVSO, I just blanked it off. just type in AAVSO. I think it's probably .com.
Mm-hmm.
But type that into your search engine, and it'll get you there. Let's see. I did have some other articles here about the Milky Way. It is thought to be as equal in mass now as the Andromeda Galaxy. Let me pop this article into our chat room. Here you go. So it's always been thought that the Andromeda galaxy was bigger than the Milky Way galaxy. Andromeda Galaxy is visible in the nighttime sky with just your eyes. If you have really dark skies and really good eyes, it appears as a little fuzzy spot in the constellation of Andromeda, a little bit towards easier to see in the northern hemisphere. And it was always thought to be I don't know, just bigger or more massive. I don't know if I have to check the dimensions on it, but there's certainly been they recalculated it using other techniques and thought now that it's actually just the same amount of mass as the Milky Way galaxy. So looks like we're going to be on equal grounds with the Andromeda Galaxy now.
And of course, there's that merger that's going to be happening in millions of years' time.
Ooh, more than that. Like billions, about 5 billion years, something like that.
But nothing to worry about. It won't affect us too badly on Earth. Neither will the fact that even if the black hole at the center of our galaxy does grow appreciably, even to a light year across, being that we're on one of the spiral arms, we are well away from harm's way with that.
Well, 5 billion years, that's about the end of the sun in the main sequence, or its shape and fuel consumption, if you want to call it, is real steady right now. 5 billion years from now, that fuel is going to run out, and its core is going to shrink down. It's going to start fusing heavier elements, which will make the outer atmosphere of the sun expand out and probably will engulf the Earth, about that time. So we don't have to worry about a collision. We're going to worry about our own sun swallowing us up and burning us up. So.
Okay. Another quick story, which I found looking at Marty's link, is Hubble data indicates the universe is growing faster than expected. This is in Astronomy Now and written by William Harwood. Mm-hmm. So basically, it's been looking for pulsating Cepheid variables in 19 remote galaxies. It's part of a project to refine the cosmic distance scale and to improve understanding on how fast the universe is expanding. So in the image that's on the link, it's the pulsating stars known as Cepheid variables are critical mile markers on the cosmic ladder, because we know of what they are intensity-wise. So they are like cosmic candles. Mm-hmm. So, of course... like glow sticks.
It's kind of like if every car had exactly the same headlight.
Yeah.
Then you could tell how far away the car was by how small the headlight appeared and how much dimmer the light appeared. So you could judge it that way. So that's what they do for judging things out in space. But you have to find something that is equal all the time or proportionally equal in brightness.
Yeah, the interesting thing is it could also mean that dark energy, whatever it is stronger than the cosmological constant built into Einstein's equation. And I think even Einstein himself admitted that the cosmological constant was a big mistake. Mm-hmm. So, as I say, it's basically... or that dark matter interacts with normal matter more strongly than previously suspected. So it's stretching the universe out, but it seems to be doing it in equal directions. Now, they think that there may be some yet unidentified subatomic particle that is responsible. However, the bottom line at the end of the day is something is not quite right with our standard model of the Big Bang and its aftermath. But maybe with the new generation of space telescopes coming into service, like the Webb, we will get further and further closer to, certainly into Planck time and to just before Event 1. I don't think we're ever going to get back that far. Oh. I don't think that's possible, but I could be totally and utterly wrong, and it's quite possible eventually, maybe in 200 or 300 years, somebody will find a way to look back to Event 1.
Maybe they can figure out a way of measuring the expansion of the background radiation. Background radiation.
But that has patches in it. It's concentrated in some areas and some other places it isn't. However, the predictions based on the Planck data, taking into account the observed effects of dark energy, is resulted in a Hubble constant of about 67 kilometers per second per megaparsec. Put another way, if all things were being equal, two galaxies 3.3 million light years apart, 1 megaparsec would be moving away from each other at about 67 kilometers per second, presumably due to the constant expansion of space. However, the Planck data now indicates a maximum upper limit of 69 kilometers per second per megaparsec. So Reese and Stefano Castano both with Space Telescope Science Institute and Johns Hopkins in Baltimore. They've led a team who used the Hubble over 6 years to try and sharply define the measurements of galactic distances, so they can more accurately calculate the Hubble constant. When you think about it, Hubble, when he was using, I believe it was Palomar, maybe in the Yerkes telescope, found the Cepheids. He then worked with very basic information. I think if Hubble was here today, he would be amazed at what we're doing. Now, but the only other thing is this team has come up with a value of 73 kilometers per second, or per second per megaparsec. So it's a 9% discrepancy. So what they're saying is you can think of the universe growing just like a child. The cosmic microwave background as a snapshot of what the child looks like at this time. So you can measure, you know how we've all been measured as a height on the door frame, we mark the date, and then everybody goes around saying, the doctors, the parents, say, gee, following normal growth charts, this child will reach a height of 6'2", or something like that when they're fully grown. Now, it's present day, the child is fully grown. This is our present universe. And now we're actually measuring the expansion rate of the universe. It's not 6'2" as predicted, it's larger. In this case, it's something faster, and it's becoming quite significant. I think we're living in brilliant times. This is going to be really cutting edge discoveries coming up. I can't wait to get the web in operation. It's going to look in near infrared, and it's going to really help improve our knowledge, I think.
Did you see the picture of from OSIRIS-REx? Picture of the moon and the Earth.
Oh yes, I remember that.
Way out there.
Yes.
Let me pop that into our chat room. One of the latest things out there. Some things to note about this picture. Let me get this in our chat here. It looks like the moon is really close to the Earth, but it's actually not.
No.
The way this picture works is the moon is in the picture actually a bit behind the Earth. So that what makes it close, and it makes the moon so bright. Otherwise, in order to get the maximum separation that they should be, the moon is like 30 Earth diameters away. So the moon's actually pretty far away. So in order to get like a nice round Earth like that and a nice round moon, really bright and close together like that, that means that the moon was mostly almost around the far side of the Earth. And they're both basically pretty much full. So that would make the moon bright enough to actually be able to photograph like that. Otherwise, if they were 90 degrees or maximum separation between the two, that means just like the left side of the Earth and the left side of the moon would be lit up, and you'd get like less than half the brightness of what we got out of this picture. So the moon is not that close to the Earth.
Because the really nice thing is, if you look at the actual image, you can actually see constellations that are visible. And the Earth-Moon system is centered in the middle of 5 stars, comprising the head of Cetus the whale. So, according to this, the bright cluster of stars in the upper left is the Pleiades in the Taurus constellation. Hamel, the brightest star in Aries, is in the upper right corner of the image. And, of course, the Earth is in the middle of 5 stars of Cetus the whale. This is great stuff.
Oh, yeah. I see the Pleiades at the upper left there.
Yeah. I remember everybody going into raptures over the pale blue dot. And this is another one of those moments. This is seeing our Earth, our moon, from so far away. What was it? They said it was 39.5 million miles away, and it's moving at a speed of 19,000 miles per hour.
I want to remind everybody doing some observing. Next Friday is full moon, so don't count on next weekend being really good for deep sky observing. So get it in while you can after moonset. Yeah, it's going to be a while for this weekend, so get a little bit of observing. The Dwarf Planet series is well primed right now. It's pretty much almost on the meridian between Gemini and Leo the Lion in the constellation of Cancer the Crab.
Yep, there's plenty of stuff out there. Go look out, enjoy it.
Mm-hmm.
And you know what the thing is? You don't need a telescope to enjoy it. You can just go into a dark spot and look up and enjoy it. Okay. Guess what, Marty?
It's just about that time.
It's about that time. This is the away team to the Miranda. Captain Savat, 3 to beam up. Energize.
All right, everybody. I want to thank everybody that's been listening in tonight. Really, really appreciate it. And everybody that's been in our chat room joining us, too. Appreciate you being in here. We'll be back again next Friday, of course. More news, more new stuff. Our New Moon Friday next time.
Yep.
Hope you all enjoyed it. Don't forget, we got more programming coming up. You can still listen to that. Will be repeated every 4 hours. Sorry, for the next 24 hours. Good night, everybody.
Say good night, Marty.
I just did.
Good night, everyone.
Good night.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
Hi, this is Tavi Greiner, Astronomy.FM's Vice President of Communications. If you enjoy our programming, please let us know with a donation to Astronomy.FM/donate. We really do rely on your support, and it's true. Every little bit counts.
AFM.
There I was, doing my thing.